50 million years ago, a lineage of hoofed land mammals began a gradual migration back into the sea. Over millennia, they lost their hind legs, developed horizontal tail flukes, and adapted entirely to saltwater. The modern result of that evolution is the North Atlantic right whale. Today, human impact has pushed this species into a severe population bottleneck. Only about 380 individuals remain. That total number obscures an even more critical reproductive crisis. Out of those few survivors, biologists estimate that only about 70 are actively reproducing females. They share their coastal migration routes and surface habitats with massive commercial shipping operations. Vessels of this scale travel at high speeds, making any collision highly lethal. After 50 million years of biological adaptation and planetary survival, the entire evolutionary line of the North Atlantic right whale faces erasure by a few decades of modern maritime commerce. In popular media, discussions about whale conservation are frequently tied to global warming. A prevalent narrative suggests that protecting whales is a primary solution for capturing carbon and reversing industrial climate change. Testing that claim requires looking at the total carbon stored in the living biomass of all marine mammals on Earth and comparing it to the amount of carbon dioxide humans actually produce. This bar chart visualizes total global anthropogenic CO2 emissions against the total carbon mass of all marine mammals. Last year, human industry emitted roughly 57 gigatons of carbon dioxide. If you combine the carbon stored in the bodies of every marine mammal, it equals less than 0.004% of that industrial output. While industrial emissions continue to scale exponentially, the biological storage capacity of the ocean's mammals remains fixed. Positioning marine biology as a defense against industrial emissions distracts from the necessity of reducing fossil fuels. Whales will not absorb our climate sins. They underpin the physical architecture of the ocean ecosystem, and their survival is a functional necessity for the health of the planet. To see that machinery at work, we have to follow them down into the mid-water column, far below the surface. Deep-diving whales execute a biological mechanism known as the whale pump. They travel into the darker depths to hunt for dense patches of prey, consuming massive quantities of deep-sea nutrients. Because they are mammals, they must eventually return to the surface to breathe. When they reach the sunlit photic zone, they expel feces and urine. This process takes heavy, trapped elements like iron and nitrogen from the deep sea and distributes them as floating fertilizer. Those nutrients trigger massive explosions of microscopic plant life. Biologists estimate that over 85% of right whales have been entangled in this gear at least once. Whales can drag heavy lines for hundreds of miles, resulting in starvation, severe tissue infections, or fatal exhaustion. Navigating ships around these animals or locating them to clear gear is incredibly difficult. Visual surveys rely entirely on spotters in airplanes or boats, a method that is ineffective at night, in heavy fog, or when the whales are submerged. To track them blindly, conservationists deploy passive acoustic monitoring. This involves a network of specialized underwater microphones anchored to the seafloor, running continuously, waiting for a specific frequency. An anchored buoy isolates a white whale's vocalization. The detection transmits to a satellite in near real time, routing to coastal labs. This data triggers dynamic management zones, legally requiring commercial vessels 65 feet or longer to reduce speed to 10 knots. Because the ocean completely conceals these giants from view, maintaining this active, listening technological net across the seabed is the only reliable way to guide them through the maze of ropes and commercial shipping lanes. A right whale's contribution to the ecosystem continues after it dies. Sinking, it eventually settles on the barren, lightless abyssal plain. This event creates a whale fall. The sudden arrival of thousands of kilograms of organic matter triggers an explosive, localized oasis of life in an environment defined by deep starvation. The deep sea usually relies on microscopic detritus drifting down from the surface. A single whale carcass delivers the equivalent of 2,000 years' worth of normal marine snow in an instant. This kicks off a complex ecological succession. Mobile scavengers like sharks and crabs strip the soft tissue over a period of months. Afterward, specialized bacteria colonize the skeleton, extracting lipids directly from the bones and producing hydrogen sulfide. This chemical process supports dense mats of microbes, which in turn feed suspension feeders. This single nutrient island can sustain tens of thousands of individual organisms and newly discovered endemic species for up to a century. The North Atlantic right whale is a foundational architect that seeds life at the sunlit surface and sustains entire alien worlds in the pitch-black abyss. Preserving the remaining 380 individuals secures the structural integrity of the ocean itself.